I'm really thrilled to be here today to share some exciting features that will supercharge your app's performance. And today I'd like to tell you a story. Hopefully you like stories. I'm going to share quite a few stories with you today actually, but not a typical fairy tales, but stories about the web performance and lazy loading. So, are you ready? What an enthusiasm, yay. Awesome. So, let me start from a very popular story about the tortoise and hare. So I'll try to reimagine that story in a context of web performance and lazy loading. So let's give it a try. Once upon a time, in a world of front-end development, developers raced to make their apps the fastest. And some of them actually believed that the only way to win the race was to preload everything. And much like the hare, they've tried to do everything at once, eagerly loading all components, images, routes, every bit of JavaScript, dumping on the user's plate the entire buffet before they even pick up the fork. Meanwhile, the REST developers, similar to the tortoise, took a little bit different approach, trying to provide things constantly, delivering a smooth user experience. And in the end, just like in the fairy tale, the tortoise, the one who took things slow, crosses the finish line first. So today I'm going to show you how sometimes the slowest approach can be actually the fastest way to win the performance race. But before, let me quickly introduce myself. I'm Jarek, I'm from Poland. I'm the team lead of the architecture team at Pushbased. Additionally, I'm the organizer of Angular Catch-up podcast, co-organizer of Angular Toronto meetup, mentor at Angular Space community. I'm also the Angular Google developer expert. You can find me on Twitter, old Twitter, as well as on LinkedIn. So feel free to reach out to me if you have any questions. Today, we're going to cover 4 key topics that are crucial to improve the performance using the lazy loading techniques. We'll start with lazy loading images. Then we'll cover lazy loading routes. We'll check the embedded views. And last but not least, we'll see why hydration makes server-side render application efficient and how incremental hydration can push it even further. And of course, in the end, we'll put everything to test with a live demo. So finger crossed. What possibly can go wrong during the live demo, right? We'll start with a lazy loading definition. I'm pretty sure many of you are aware what is it, but for those who are not, it's a very powerful technique that allows us to delay the initialization of certain part of our application until they are actually needed. So instead of loading everything up front, we can load parts of our application on demand. And this technique brings lots of different benefits, including the reducing bundle size and speeding up the initial loading time. Now, let's walk through all mentioned techniques and check how they can help us to improve the performance, starting with the images. And let's start with another story to bring you a context of lazy loading images. So imagine you are walking into a restaurant and ordering a food. And instead of serving you the food you requested, the kitchen decides to prepare you the entire menu all at once, just in case you might order something else. Why not, right? And you're sitting there hungry, waiting and waiting until the chef's trying to cook everything. And this is something that might happen if your application or loads all images up front, even the ones that user might never see. So browser got this, I call it a bad habit, trying to load every image the moment the page is loaded, even the ones that are buried down in the sections that user might never scroll to. And of course, this is very inefficient and slow things down. So Angular brought a really great tool to improve and optimize images, ensuring they load faster and without really compromising the quality. And the ng-optimize image directive is in the center of it. Right, so let's walk through different attributes of this directive and verify how they can help us to improve the performance. Let's start with lazy images. So before releasing ng-optimize image directive, Google and Aurora team measured how many applications in general use the lazy loading images in their applications. And it turns out that it was only 7.8%. So I do believe, like many of developers are familiar with lazy loading concept, however, they are not applying this concept in their applications. And this is why Angular decides to automatically lazy loads every image when they comes into the viewport, meaning that users don't have to wait for any off-screen images before they interacting within the page. And this small change brought a huge difference, especially for users with slower networks where they don't really need to wait for images that they haven't even seen. Of course, not every image should be lazy loaded. There are some crucial key images that should be prioritized, and this is where the priority attribute comes into play, ensuring that the image will be loaded eagerly, meaning there will be no any additional dilation. With fetch priority set to high, meaning our browser will prioritize loading these resources, booking enough of memory and resources to actually load those media. And for server-side render applications, all priority images will get this additional rel equal preload attribute, meaning the images will be preloaded before rendered. The page will speed up even more the initial loading time. Right, switching to the lazy loading routes to ensure the efficient navigation. So let me bring you another story to illustrate the concept. This concept hopefully will be familiar to some of us. Imagine that after countless hours of working, you finally found this time slot to watch a single movie with your family. And you've been waiting for this moment with anticipation, so you are happy, your wife is probably even more happier, your kids are excited, even like your dog and a cat looks a little bit different. So when this moment actually arrives, you all settle down in the couch, opening popcorn, turning on the movie you selected, and instead of starting watching the movie, you're staring at this loading indicator because your app decides to load not only the movie you've selected, but all movies from its libraries, just in case you might want to watch something else. Why not? So you are again waiting and waiting. Your wife is probably not that happy anymore, and this magic moment just gone immediately. So for lazy loading routes, Angular automatically generates a separate JavaScript chunk related with the component that should be loaded when user enters some particular route. So only this essential code will be loaded into the browser when user enters some particular route. And to illustrate you this concept, let's consider the following example. Let's say we have a routing configuration with 3 different components all set to be eagerly loaded. So without lazy loading, Angular by default will bundle all these 3 components into one big JavaScript file. Now, browser, before rendering the first page, need to process everything, and that definitely will increase this time and deliver the sluggish user experience. So all these 3 components will be loaded right away, regardless of any would be needed and used immediately or not. So in this particular example, all these 3 components will be bundled into main.js bundle, which, as you can see, takes 30.33 kilobytes. Now, let's take a look at how the situation looks like with lazy loading. So lazy loading is built-in mechanism. All we need to do to lazy load particular route is to utilize this load component, and that's it. So when user enters, for example, the movies route, the movies list component, the relevant component would be loaded, nothing else. So when we'll get back to our example with 3 different components, we'll be able to see that our main.js file takes 4.39 kilobytes, which is over 70% less, only by replacing the eager loading with lazy loading things. Additionally, we can see lazy chunk files. Each represent lazy loading chunk with specific component that will be loaded once user enter particular navigation. Awesome. What if I told you that we can not only load the entire pages, the entire routes, but also parts of the pages as well? So Angular introduced this a very cool feature that is called the deferrable views, which allow us to load parts of our application when user interacts with this, while the other sections are still kind of not loaded. So to illustrate this concept, let me bring you another story. Again, let's say we are in the restaurant, this time with multi-course dish. And let's say you are ordering a multiple meals. And instead of the waiter dumping all the dishes you requested at once, crowding your space, making it overwhelming, he serves each course one by one only when we are ready for it, right? So we are starting with appetizers, then when we are ready, it's time for the main course, and after main course, my favorite dessert. So this is how the defer blocks are working. So instead of loading everything up front, we can load each component only if they are needed. And this is very useful for applications with lots of non-essential, non-crucial content that doesn't really need to be rendered right away, but can wait until it's actually needed. And when you are dealing with components like tabs, accordions, chats, some expandable cards, this is the way to go to improve the performance. So in this section, we'll talk about the defer directive itself, and also we'll check when exactly, how much control we'll have over those lazy loaded chunks, and to decide when exactly those parts would be loaded. So Angular has made it super easy to implement lazy loading parts of our application, the deferrable views. All we need to do is to wrap component or components with this defer directive, and by doing this, Angular will delay rendering until the condition or interaction is happening. So in this particular case, we are saying, please load our app recently watched component on idle, meaning there is no immediate pending tasks. So this is the default behavior. If we'll not specify any argument, it will be treated as on idle. So those two examples are equal. Now, as you can see, when we build that part of code, we'll get something similarly to what we've seen when I've talked about the lazy loading routes. So the piece of the deferrable views code is extracted into the lazy loaded chunk and will be loaded once it's actually needed. So it's a very great way to reduce our main.js bundle size. Now we have lots of control on when exactly we will load those lazy loaded chunks. So as mentioned on idle, we load this particular view when there is no immediate pending tasks. On viewport, when this part will enter the viewport, and here Angular is using the intersection observable, something that has been used with CDK breakdown observer implementation to verify the size of the screen. It's a very powerful and fast algorithm. On interaction, when user click on some part of the page, and then it means the deferrable views will be loaded. On over, very similar, but when we mouse over on this part, on intermediate, meaning right after all eagerly loaded content is fetched, so right the eager components are loaded, we'll start to load lazy loading things, and on timer after some given time. Now we can also load parts of the page when some condition is met. So in this particular case, when condition returns true, the app recently watched component will be loaded. And we can also combine in a chain different triggers. So in this example, we can say load this app recently watched component when user click on some ng template part 5 seconds after click, for example, right? Now, I was thinking quite a lot about the example how to illustrate the hydration concept, and I think I found it. So hydration is like waking up from a deep sleep. You know, we are technically awake, however, we are not quite ready for the interaction with different people. We are not quite ready to face the world yet. At least I'm not, right? We need to hydrate ourselves. I need like 2 or 3 coffees to start normal thinking and interact with different people. So let's try to understand how things work without hydration first. So without hydration, our server-side render apps is like this gorgeous, delicious, tasty cake you can't eat yet. You have to wait and wait before you take a bite and enjoy it fully, right? So the typical server-side rendering process looks like the following. The server generates HTML and sends it to the client. And this HTML is a static HTML. So user can see the content immediately, however, he can't really interact with it yet. The interaction comes with JavaScript. So the JavaScript is loaded and executed, and then our page becomes interactive. And this can cause some side effects and some issues. First one is a flickering effect, right? So when we finish executing the JavaScript, the entire content is replaced. So our pre-generated static HTML is replaced by the new one, regenerated one. So for like a few milliseconds, there might be this switching content effects. And of course, the second side effect is like a longer time, initial time, because we are rebuilding the same things twice. The second is the user experience. So there is this dilation between when the page is visible for the user and when it actually becomes interactive to the user. So the longer the JavaScript takes to load, the longer user waits to start interacting within the app, right? Now, let's take a look how things change with Angular hydration. So with Angular hydration, the same gorgeous, delicious cake becomes instantly ready to enjoy the moment it appears. So no more wait, just cut it and enjoy. So instead of staring of the static page while the JavaScript is loading, setting up all the listeners, Angular hydrates our page, making it almost right away interactive, basically. So what's the differences? The server pre-renders HTML and sends it to the client. So the user can see the content immediately, but he cannot really interact with it. So far, so good. But we are not stopping there. The same HTML, static one, is reused, and the JavaScript is loaded, Angular is kicking, bootstrap the application, and even if the JavaScript execution is not quite ready, we are ready to go with interaction with our page. So there's two major differences. First one is the static content is reused, so we are not redo things twice, which speed up the whole process. The second is that once the Angular kicks in and bootstrap our Angular application, thanks to event replay, we are starting to recording our actions. So in time, basically, even if the application is not quite ready for interaction, we put on the stack all our actions. So once the JavaScript is executed, it's like pressing the play button and all the actions from the stack are taken, so nothing is missed. So the user don't have to wait for the page to become interactive after seeing it that much. Right. Oh, sorry. So to apply hydration in Angular application is pretty straightforward process. All we need to do is to provide client hydration provider into the providers array during our bootstrap application process. And when it's done, we can start taking advantage of all its benefits right away. Now, we know that hydration can speed up the initial loading time. However, incremental hydration can push it even further. So instead of activating the entire page at once up front, Angular allows us to selectively hydrate different parts of our application while the other sections remain still static until needed. So the process looks at the beginning similar. So once again, the server generates this static HTML, send it to the client. The client can see immediately the content. And the biggest difference is that we are not downloading the entire JavaScript. We are downloading and executing only the JavaScript responsible for the parts that user interacts with, right? So that helps us to postpone the execution of the JavaScript in time and speeding up the initial loading time. So yeah, developer can have a full control on when exactly hydrate those different parts and make them interactive. So similar to what we've seen with the deferrable views, Angular provides a variety of triggers to control the hydration behavior. So on idle means hydrate the content when there is no immediate pending tasks. On viewport, when it enters the viewport. On interaction, when we, for example, click or key press. On over, when we mouse over. On timer, after given time, when the condition is met. And hydrate never. At the beginning, I was kind of confused why we need hydrate never in hydration process. And that might be very useful when we are pretty sure we've got a static content. So for example, when there's a footer with hard-coded text, we should never ever think of it as interactive part of our application, and then we can say it, never hydrate this part. So to implement incremental hydration, all we need to do is to apply this with partial hydration argument into our provide client hydration provider, and from that moment we can start utilize the defer directive with hydrate on argument. Right, so here we can see the incremental hydration in action. So as you can see, we are getting a static page at the beginning, and the hydration is set to hydrate on over. When we mouse over each component, it gets hydrated, and this way we can postpone the execution and downloading of the JavaScript related for each of these components in time. And yeah, enough of slides. It's time for an action. So let's demonstrate how each of these techniques is working, and hopefully by the end you'll be able to see how faster the application can be when we'll be a little bit lazy. So I have prepared a fairly simple application for this talk. Let me quickly show you that application. So we have application about the movies. Try to pick some topic that everybody's are familiar with. We've got on the top the top rated movies. Here on the bottom we've got section with recently watched movies. On the second route we have all movies with some details, ratings. This section is a little bit more interactive, so we can add, for example, the Pulp Fiction to watched and to favorites. We'll be able to see this Pulp Fiction movie to be added to the recently watched movies section, and we can expand particular movies to get some details, including the description and the cast. So that's pretty much it. Let's quickly review the code. So we've got these two routes. The home component, the default route loads this home component. This home component has on this top the app top rated container. This app top rated container just displays in a loop top rated movies. Nothing else. The app movie is fairly simple. It expects the movie object as an input property binding. It's a signal, and the second signal is priority. It's used to verify how the images should be loaded, if we should treat them as priorities or lazy loaded images. Then there's nothing special here. When we'll get back to our home component, the second component is recently watched movie. It's fairly simple component, so we get all the movies from our store and filter them by the is watched flag. it uses this app movies component as well, which expect the same input property bindings, movies, and its priority. The second route, movie list, displays all movies that are fetched from the store, and on the bottom of this on this template we'll be able to see this expand thing. So after we click the arrow icon, will display all these details for this particular movie. So let's try to verify the initial performance score using Lighthouse. So let me remove the this folder. Oh, there's no this folder. Awesome. Let's build the application. Oh, and let me start the HTTP server. I forgot about one thing. Let me. Oh yes, sorry. I thought I forgot about this -c-1 to skip the cache. And let's measure the performance. Finger crossed it will not be above the 90 or something like that, because there will be nothing to improve. But let's check. Yeah, 58, not that bad. However, this application is very tiny and uses Angular, I believe, version 20 in the default form. So I would expect things will go better. So let's check how we can improve this Lighthouse score using the techniques I did mentioned. So first of all, let's run the application once again, and let's check how many bundles we'll have. We'll see our main bundle is eagerly loaded and takes 54.82 kilobytes, meaning we don't have any lazy loading routes. So let's change that. So instead of loading the movie component, where is it?
Derek, font size, zoom in, please.
Zoom, okay,
Yes.
Not a problem.
Eighteen or 20?
It was 26.
Then go 32.
Let me set 40.
I can't see even a letter from here. Yeah, that's fine, that's perfect.
Is it better? Great. So yeah, let's apply lazy loading. We said that all we need to do is to use the lazy component. Then we can simply say import the movie list component from the movie list file and lazy load it. Once we'll rerun our application, we'll be able to see that movie list component has been extracted. Is there any way to increase this font? I don't know. Do you see it well or not really? Oh, somewhere here, fonts, size 40. Aye. Better? Awesome. So we can see that for our movie list component, we've got like extracted lazy chunk file, and right now our main.js takes only 29, something over 29 kilobytes instead of 58. So we reduce our bundle size almost double. Now, what we can see as well is when we run our application and we'll verify all these images that should be prioritized, right? Angular is screaming, hey, the ng optimize image directive has detected that this image is the largest contentful paint element, but was not marked as priority. So even if we'll skip that, even if we'll miss that, Angular will let us know that there are some images that should be marked as priorities because they are a crucial part of our page and as part of the LCP element, so should be prioritized. Also, when we'll expect those, let me maybe goes here, not that big. If we'll expect each of this image, we'll see each is set to fetch priority auto and loading lazy because Angular will set all non-priorities images as lazy loaded, right? So let's change that. And those images are part of our top-rated container. So, as I said, there is an input property binding that expects the isPriority signal. Application is rebuilt. Awesome. And now, when we'll verify our image, we'll see that the loading is set to eager with fetch priority set to high. So we've got all these most priority images to be prioritized by the browser. Now, what else we can do? We said that we should use the deferrable views for non-essential content that doesn't really need to be rendered right away, right? So I think this expanded component is not the really essential content because it can be rendered once user clicked on this arrow button. So let's check that and let's improve this. So app movie expanded, we said, hey, please load this component on defer in the defer block when user interact with this particular matte icon element. So when the user click on it, for example, we should load the app movie expanded element. To show you this, let me quickly build the application, and we'll be able to verify if a separate chunk for this expanded element has been created. We can see we've got this movie expanded component in our lazy chunk files. So I do expect this element to be loaded right away when we interact within this arrow button. Oh. Okay. Oh, 8080, I'm sorry. So 8080 port is this one. And when we'll go to the network tab, when we'll try to clear all the downloaded chunks, we'll go to the movies, we'll see that the separate chunk is loaded because it's part of lazy loading routes. However, when we click right now our arrow button, this additional JavaScript is loaded into the browser, so the execution of this particular part of the code has been postponed until user click on particular element. Right, what else can we do? There's one last thing we can do, and as we can see when we are on the home page, we don't see this recently watched component section, at least not at the beginning. So what we can do, we can hydrate those bottom section only when it enters the viewport, right? So when user starts scrolling and when intersection observable will detect that this is the part of the viewport, it will load this additional JavaScript relevant to this section. So let's quickly do that. To apply server-side render application, all we need to do is to use the ng-add angular SSR command. This command will create some default configuration for the server-side render application. With some default configuration, we'll have some few new files created, like main server, app config server, and server.ts, but this is not the most important thing. We'll be able to see also this is duplicated, so I'll just remove it. We also see that we'll have provide client hydration with event replay and with incremental hydration in place. So right now, let's try to say, please hydrate this particular element when it's entered the viewport. All right. Now, when we added this SSR package, Angular by default will create as a package.json script that will allow us to serve the server-side application. I think I need to build the application first. Here it is. And then we'll serve our application with this command. It's available on port 4000. So let me quickly run this application. All right. So we can see the top rated movies. When we scroll down, you can see this additional chunk is loaded once we enter the viewport with this recently watched section. So again, we loaded and postponed the JavaScript execution in time once user scroll to this particular section. As you can see, it's fairly straightforward. We don't have to implement by ourselves any algorithm with intersections, detections, or anything else. Everything is built in. So that's all these 4 techniques to improve the performance. And after spending 5-10 minutes, let's verify the performance after those few changes. So as you remembered, we've got 59, I guess, as the initial Lighthouse score before these improvements. We have applied some few changes, and after all, we've got 97, which is almost doubled, right? And we haven't spent like much time for having or to reach that kind of bump of performance score. Yeah, I think that's pretty much it. So yeah, thank you very much. If you want to play with this code, you can scan the QR code and you can get the source code. Hopefully, I did show that being a little bit lazy in a right way will allow us to provide like a huge performance bump. So go for it, be lazy, and create incredible fast applications. Thank you very much.
Applause! Wonderful. Very, very nice talk.
Thank you.
Are there questions? So many. Look at this. Where do I start? At the very back this time.
Thank you. I have a question regarding the dependencies. That whenever we decide, okay, some part of template or some of the components should be lazily loaded, then how exactly the dependencies are being maintained. For example, my current component would have maybe many dependent components, and maybe I'm reusing them somewhere else, maybe I'm not reusing somewhere else, and how exactly it works.
So the general rule is that it's actually implemented in a very optimized way. If there's any similar code, the component you are trying to lazy load, right, reused in a part of the code that is eagerly loaded, this component is already loaded into the browser and will not be lazy loaded, so there will be no duplication. So if you are using the deferrable views first time for the very unique component that is never eagerly loaded anywhere else, it will be lazy loaded for your browser because it's required to be displayed, right? But if this component is part of eagerly loaded bundle that has been already loaded into the browser, it will never be loaded once again to improve the performance, so will not redo the same thing twice.
And even though I mark it as lazily loaded component, let's say,
Yes.
then also it will differ it out and it will
be treated as already
Exactly.
loaded once.
Okay.
So if you
And do we get any compile time errors or we don't get?
what do you mean?
So my component is being used somewhere else,
Mhm.
and it is supposed to be eagerly loaded.
Yes.
But I'm marking it as lazily loaded.
Yes.
Then do I get? I'm not sure because I haven't done that. But do we get compile time error, or
No.
it will just load it eagerly?
No, it will take the fastest required approach. So if your component is eagerly loaded at the and at the same time lazily loaded, it will be eagerly loaded because something that will happen as a first into the browser. And of course, you know, eagerly loading is happening first. So this lazy loading will be skipped.
Okay, got it.
It will be rendered without any error, just to clarify that, right? If it's already part of the eagerly loaded bundle, it will be displayed but not lazy loaded once again.
And my second question is, whenever we lazily load some small part of a template, then how exactly it is being managed? That okay, this particular chunk of HTML would be loaded lazily, and rest of the things would be low. How Angular keeps track of it?
I'm not sure I understand your question. Basically, so we have like small amount of HTML code, right?
Yeah.
That we are trying to lazy load it, and what we are trying to do with this small piece of code.
maybe it's some interactive content, or maybe it's a static content, or maybe some um, huge heavy image or something like that. But only that, I mean, using defer, maybe I'm just trying to lazily load that particular part of the template. But that component is, maybe let's say, that component is being loaded eagerly. Then how exactly it keeps track that, okay, only this chunk of this component is lazily loaded?
The defer directive identify all these chunks component to be lazily loaded. So they are kind of identify the code that should be extracted into the separate chunk. However, like I said, if the same component has been already loaded into the browser, for optimization purposes, it will not be reloaded once again.
Okay.
If it's not part of any eagerly loaded chunk, then it will be taken and load as a separate chunk into the browser.
Okay, yeah, thank you so much.
Yeah, thank you.
Thank you so much. Well, thanks for the talk. I have two questions. The first one is regarding the last feature you showed, the hydration.
Yeah, incremental one, right?
Yeah.
Yeah.
Does that lock you in to using the Angular web server, or is it still possible to use any arbitrary web server like Nginx or Tomcat when using that approach? So does it require a server that's executing some JavaScript, or?
It does require server, because the HTML is generated on the server side and sent to the client.
And there's no way to like pre-generate that part.
Pre-generate, it's still a
like
part.
At compile time, not at runtime.
It's still part of the server-side rendering, the pre-rendering, right? So you still need a server to do that.
Okay.
Basically.
And the second question is a bit more in depth, but when it comes to lazy loading routes and I guess also the components, what are best practices, or how would you deal with redeployments? Because
with what?
Redeployments of your application. Because I guess the chunks might change. So any users that are currently on your application, if they try to access that route, they will get a client-side error because maybe that chunk does not exist anymore on the backend, and the browser cannot load that page. So how would you like deal with stuff like that?
I don't think it's working the way you think it's working basically. So when you are loading the chunks into the browser, you are using the chunks your browser are already loaded. Those chunks are not replaced after each redeployment. Once you will refresh the page, the new chunks will be loaded into the browser, and then the content will be replaced. But if you have already launched the page and load all different chunks, and meantime the new release happens, still your browser will use the chunks that are loaded into your browser basically. So you'll not get any out of sync error probably. But
like imagine the case where I just go to the home page in my application, and like the second page is a lazy route, and the user has only accessed the home page. Then I do the redeploy, and then they try to access the second page. Then they don't have the second page yet in their like browser memory. No, it will just get the newest version of the lazy loaded routes because it has not been loaded into your browser. Okay. So if it's not in your local browser memory, it will fetch the newest version from the server. But does it like know the path of that? I mean, I guess it will load it by URL. And you mean the routing configuration will change meantime, or maybe the chunk identifier changes because the component was changed. So the chunk, they have this identifier at the end, and maybe that one changes. Do you have any best practices there, how to deal with that?
I think, best practice is to identify or to minimize chunk with name chunk attributes set to false to get like on production to get like very unique chunk names, basically to be able to identify what is up to date, what is not up to date, basically. And that might be like, I'm not sure what would be the final behavior of the browser if meantime the chunks will be changed. However, I do expect it will, if it's not in your local browser memory, all the newest chunks will be fetched. But I might get wrong. Need to verify that. Good question.
Thanks for the answer.
Yeah.
I would just add a little bit to that question because I believe it's a massively cool question. First of all, you have chunk hashing. If you try to fetch something that is not on the server anymore, you get a failure, you get an error, it will not work, your example will fail. Because you fetch a page, you update the files on the server, and then you try to fetch a file that is not there anymore. Obviously will fail. But you mentioned a really interesting problem. In Angular, you just have an error. If you think about a little bit more modern or exotic frameworks like Quick or Viz from Google, they have the lazy loading principles, like over-exaggregatedly, like optimized. They go not on component level, they go on event listener level. So they have everything is a mini chunk. And they have a lot of applications that are extremely long running. Like not 10 days, but maybe they run for 3 months without any change there, any refresh, nothing. And there they face a lot of those problems and they have no good solution at all. Like they hack around, they try to like avoid, make some auto refreshes in between, but if you redeploy something and you change something, you most probably will fuck it up in the other end.
You will need to probably implement some push notification or anything that will let you know as a user that things will change. Please refresh the page. It's something that can work similar to progressive web applications, that hey, the new versions is recently has been released, basically please refresh page to get the new content.
Yeah, so exactly I wanted to refer that we had this issue because our application is a somewhere it's running for weeks. And that was an actual problem. So what you can do is that you can essentially specify the name of the chunk. What we are doing is that we have version numbering and we are appending the version numbering to the specific chunk. And if you cannot load the chunk, then we are saying that the user is notified that the application is changed, and then it will restart. So there is an option to name your chunk to avoid that issue. But my question is that I never use server-side rendering, and for example, we are using in a lot of places virtual CDK scrolling and so on, which has a very smart approach to calculate all the elements and so on and so on. So it's not waiting until something is in the viewport, but it's like doing it beforehand. It's in the viewport. Is there an option for the server-side rendering to not load something when it's in viewport, but when it's like almost in the viewport, and like specify how many pixels you need?
Custom implementation, probably. I'm not sure how many pixels before the intersection observable detects something is on the viewport. But as far as I know, it measures the width and height of the viewport itself and calculates when exactly, it's not like the particular component will enter to the pixels, the viewport, and then it's detected as it's entered the viewport. It's happening a little bit before, but how much before we have, very hard to say. If you would like to specify, like, please load me this particular section 50 pixels before it enters the viewport, probably you'll need to kind of extend the implementation of intersection observable and just use the mechanism that is working under the hood within some additional configuration there. Yeah, at least this is how I would approach that.
Hello, thank you for the talk. I just have a quick question. So, if you have server-side rendering enabled, and is there a difference between defer on viewport or defer hydrate on viewport, or is it basically the same?
Yeah. So, defer blocks. They working very similar, but there is like a bit different. So the defer blocks are not really required any server. Those are working on local environment without really setting the application to be server rendered app. The incremental hydration requires this server to generate the HTML and send it to the client, right? Both lazy load chunk of a JavaScript that is related with the part that user interacts with or when the condition is met and so on. But I call that, for me, those are like a little bit different processes because in hydration we are kind of activating the code, means hydrate it, because what we are seeing is just a static page, right? In the when we are applying the deferrable views, it's like normal lazy loading mechanism. So the chunk is extracted and loaded into the browser, and that's it. There's nothing like static page, HTML, or anything like that. So it's kind of similar mechanism, but in like a little bit different environments, I would say.
But so to summarize, is it the template comes before the code?
The
or
JavaScript in incremental hydration.
it comes before?
Yes.
Okay.
Yes, so user can see the content, but he can't really interact with it. And Angular team, as you can see, because incremental hydration utilizes the defer directive, right? So they have highly used these defer blocks to implement the incremental hydration. So those mechanisms work similarly because both use the same defer directive under the hood.
Okay, thank you. Thank you.
Yeah, thank you.
Thank you. I have just one last question, or maybe two short questions. Well, it's one short and one. Yeah. No, when you said this, that you can put multiple things like on interaction and on 5 seconds delay, you said and that when you click it, there's a 5-second delay and then it loads. Didn't you mean that the first one which applies? So either it's interaction, then it's loaded, or if 5 seconds.
So when user click, 5 seconds after this click, so those conditions, those triggers, implements the and operator, not or. So it's not like 5 seconds right after loading the page or an interaction. It's like one and another. You can build any chain. What is best practice is to avoid the repeated nested conditions in the repeated nested triggers, the same triggers basically, or the same conditions, because once it returns true, for example, the nested one will be automatically loaded, probably, right?
Okay.
So the best practice is to avoid the redundant triggers in a nested blocks.
So it's really that when you on interaction and 5 seconds that you click on it and then the user has to wait 5 seconds till it loads?
Yeah.
Oh, okay, cool. And the second question was on the no hydration. Because you have, like, if you put like you put the footer example, and where you actually know that the footer has no dynamic context is actually on the components. You design a component, you know that it has no, but you define that it has no hydration outside. So where you use it, you have to know that you have to wrap this component in the no hydration. So wouldn't it be better to have a tag on the component that it says no hydration?
No, so when there is like no hydration, this wrapped component with no high rate on no or high rate on never probably will never be hydrated, meaning this part of the page will be always static.
Okay. Yeah.
There will be no interaction.
Yes. Yeah.
Right. So if we clearly know that we have parts of our page that are hard-coded, there is no interaction, and we can serve those parts as static HTML. We can say high-rate never, and those parts will be never hydrated, meaning the JavaScript related to these parts will never be loaded into the browser.
Yeah, exactly. But I mean, wouldn't it? Yeah. Okay. So because you have to.
Probably, if you clearly know that those parts are static, hard-coded, there is no JavaScript related with these elements, probably, or I don't know. Maybe I get you a little bit wrong, because if you have a component, you have to create a component class, right? You have to create and define the component template, and then you put this component as a footer component, right? It means that the JavaScript for this particular component will need to be loaded into the browser to render it properly. But it means about not rendering, but rather interaction with the user.
No interactions and no hit.
Yeah.
So the whole code is, because if you have a component, it's like internally it creates the different tags with it, as far as I understand the component. So if it just can use the HTML. But yeah, I think it's getting a bit too detailed, so I will give up.
Thank you. I was just thinking about virtual scrolling and infinite scrolling. So
virtual scrolling and what?
Infinite scrolling and virtual scrolling.
Yeah.
So with the defer and the interaction with expandable items, it would be a great way to optimize that, because there's less content in there, or DOM elements. But isn't there the problem that I could mess up with the existing libraries? So if I use, for example, defer with viewport, could this mess up the calculation that runs inside such libraries? For example, if I'm using not fixed heights, but variable ones?
Yeah, that's a good point, but I would say don't try to implement the same functionality using two different approaches. If you are trying to apply something like virtual scroll or infinity scroll, either you go with a third-party library, or if you want, like, you catch it well, it's fairly easy to apply the deferrable views and use the on viewport to just make it work out of the box without bigger problems. I'm not sure how the library will behave once you will mix those two things. My best guess would be I don't know, the JavaScript will be loaded if the intersection observable will detect this part of the page to be loaded before the library will detect it. Probably the JavaScript will be loaded into the browser, but the content will be shown based on the custom library rendering things. Because deferrable views is more about not rendering but lazy loading things, right? We are loading into the browser the piece of the code with relevant component, and it doesn't mean it needs to be rendered or not, basically. By default, it's visible, it's becoming visible. However, if there's like any third-party library that can block this rendering, probably this hidden thing will be still valid. And that will be my just best guess, but I have never tried to mix those two things together. I'm not sure if that's the best practice.
Okay, thank you.
Yeah.
Just a last question, sorry. Is there a best practice to maybe differ everything what I can, or
Differ what?
all the possible things to differ? But in the way, for example, if you have a really long page and you try to differ all the blocks what's not on the viewport, and the user starts scrolling really fast, then it's gonna need some time to see those elements, and maybe it's also ruining the whole experience for the user.
Yes. So
Is there a balance maybe between?
I would say when you want to, when the initial loading time is really important for you, the LCP, you should lazy load things as much as possible, right? Because it's more about the user experience. They don't want to wait for the content to be rendered, right? And I think that's the best practice in general. We should lazy load as many things as possible. What we should avoid is not actually the lazy loading, but amount of requests to the backend. So, you know, if you kind of get the content from the server, for example, and once you scroll, you are requesting the server, hey, give me the content. This is something that you should keep balanced, because sometimes amount of HTTP requests are more heavier than just one big request with the whole entire content. But for the client side, I think it's like the best approach to lazy load as much as possible. You will get like the initial time loading most optimized, basically.
Thank you.
A last round of applause, please.